In 1974, Ivan Long, clinical prosthetist, saw an X-ray of an amputee standing with his prosthesis, equal weight on both feet, heels 2 inches apart and toes 3 inches apart. After seeing the amputated femur in such abduction, he realized that the quadrilateral socket and standard alignment procedures were not adequate for an above-knee limb. In 1975, the Journal of the American Orthotic and Prosthetic Association published his article, Allowing Normal Adduction of Femur in Above-Knee Amputations. Abduction was caused by the quadrilateral socket being entirely too large in the ML dimension and too tight in the AP dimension. The ischium sits on top of the seat at best, and a couple of inches above it in most fittings. The X-ray shows the lateral wall to be several inches away from the femur, except at the most distal point. When the femur exerts force against the lateral wall in weight bearing, the quadrilateral socket moves laterally immediately, because the ischium has no effect on stopping this shift. With the ischial containment socket, the ischium is inside the socket, preventing lateral shifting of the socket during weight bearing. This was the start of the evolution of the ischial containment socket. Quoting Ivan Long, the original radiographical study in 1974 was to study femoral alignment, not socket shape. This study proved how little we knew about proper alignment of the above-knee prosthesis and led to the use of Long's line for improved adduction angle. Another aspect of socket design is the interface. In the same time period as Ivan Long and the development of the ischial containment socket, the Icelandic roll-on silicone socket, or IceROS, was developed by Ossur. The IceROS interface aims to disperse peak pressures, transfer shear and rotational forces between the liner and the socket, and provide suspension. Silicone was chosen as material because of its biocompatible properties, proven use in medical applications, and good elastic properties, meaning it conforms to the residual limb shape and easy to don and doff, controls soft tissues, and acts as reliable suspension. Good mechanical properties leads to high tear strength, and the material is hygienic due to its smooth surface that is easy to clean and maintain. Besides the comfort and protection solutions IceROS addresses, a challenge confronted by conventional interface systems was that of suspension, as this resulted in pistoning inside the socket. Pistoning movement in socket results in higher energy expenditure, reduced control of the prosthesis, reduced proprioception, increased shear and frictional forces, injury to skin and soft tissue. As a solution to this pistoning problem, the first hyperbaric sealing membrane suspension option was introduced by IceROS, with the benefits of reduced pistoning, a lower energy expenditure, increased control of the prosthesis, increased proprioception, decreased shear and frictional forces, and increased rotational control. Further hyperbaric suspension systems were introduced with multi-seal configuration, leading to larger seal and contact surface area, superior suspension, and in 2 studies, multi-seal configuration showed to decrease pistoning compared to IceROS locking conventional systems by 71%. The latest development in the hyperbaric seal-in interface is the Ceilin XTF. It's a combination of a seal-in ring and specifically designed liner. The liner and the seal ring is chosen independent of each other to match the patient's anatomy. Seal placement is up to the practitioner's and patient's discretion. The product elements are comprised of sealing bands of silicone matted for ease of donning while providing the necessary airtight seal, also reported to improve rotational stability in the socket. A 2-tone fabric covers the whole liner. Durability is greatly enhanced over previous IceROS TF liners. Seal-in X ring with volume adaptive blades. Proprietary silicone blend common to other IceROS TF liners. The new distal end is thinner than before, 9 mm, to allow the liner fit on the stump shape closely. The liner functions by dynamic seal created between the seal bands on the liner and the seal ring bridging the space to the socket wall. The volume adaptive blades resist collapsing of the seal in difficult areas, keeping the seal lip expanded towards the socket inner wall. Dimensions of the new Ceilin X TF. Ceilin bands on the liner are spaced 25 mm apart. It is recommended to place the ring over two seal bands so that one band is visible just below and one just above the seal ring. IceROS Ceilin X TF is approximately 5 cm longer than previous IceROS TF models. Distal end is 5 mm thinner than previous models. Standard sizes range from 25 to 55, whereas conical sizes range from 23 to 40. Seal ring sizes range from 26 to 70. Tips and tricks. Retrofit into existing X5 or HSM sockets has not been consistently positive. Moving a ring one notch proximal upon volume loss is common tactics to keep sealing during the day. Some patients have obtained good results with two seal rings to deal with muscle movement inside the socket. In that case, one seal takes over the other depending on the instantaneous shape. Socks can be used above or below the seal ring. Take care not to tuck a sock under the proximal wall. That is where the ring is sealing to the liner. For size selection of the Ceilin X TF liner, the conventional IceROS method is used. Measure 4 cm from the distal end. This height, take a circumference measurement under the slightest of tension. Choose the liner size matching this, or choose one size smaller. Also, take a measurement at the perineum. Refer to your IceROS liner profile chart first, classifying the limb length as either short, medium or long. Now use your IceROS size and your perineum measurement to determine a standard or conical profile on the chart. Determining the seal placement is up to the practitioner's discretion. Take a circumference at slight tension and choose the seal ring size one size smaller than measured. It is recommended washing the liner before patient donning. Handle the liner with care and avoid pinching with fingernails. Instruct your patient to do the same. Ossur recommends clean and simple soap for cleaning the liner. Use lukewarm water and hand wash. Next, rinse thoroughly and dry with a lint-free towel. Don the liner with total contact of the residuum. There should be no air between the liner surface and the skin. Extend the donning process up to the perineum and mark medial height. At this height, mark and cut a U-shaped channel suitable for casting purposes. Using the IceROS Curve Master is recommended for this. as it will result in a rounder shaped silicone edge compared to a scissor cut and preventing the textile cover from fraying out. Check the size of your Ceilin ring. A too small ring will display concave edges and liner constriction. The correct size ring can be placed snugly with edges displaying in line with the liner profile. Preparation prior to casting. The instruments needed are calipers, angulometer, measurement tape, plaster scissors, pen and indelible pencil, 1 and 2 inch elastics, plaster bandages, cling film, goniometer and measurement form. Cover the casting surface with cling film, creating a smooth, protective foundation to work on. The ischium should be palpated with the fingers contacting the most distal portion, whereas too far anterior on the ramus will result in discomfort and too far posterior loss in containment. On the lateral aspect, the 2-inch elastic should cross over the greater trochanter. Be sure to define the trochanter as it will later reflect in the cast. Mark the anterior superior iliac crest. The elastic should aim to pre-shape the return on the medial brim. To locate the adductor longus muscle, ask the patient to adduct the residuum, firing the muscle against resistance. Estimate the lateral trim line by illustrating a half-round shape over the greater trochanter. Moving to the posterior aspect, the line swoops below the curvature created by the gluteus maximus. The lateral convexity leads into a concave shape below the ASIS and swoops down into the medial border. Locate by palpation the distal lateral end of the femur and define. Brief your patient prior to casting as to his or her posture. The hip should be level and the residuum should be at minimum flexion and maximum adduction. Record the maximum adduction angle. To measure the minimum hip flexion angle, locate the iliac crest and ask the patient to extend the hip until a pelvic motion can be felt on the iliac crest. Record this angle. Demonstrate and guide the patient to where fingers will be positioned during the cast. One caliper measurement should be taken inferior to the ischium to lateral femur. Next, record the caliper measurement medial to the ischium. A soft tissue caliper measurement should be taken as reference 60 mm inferior to ischium. Measure distal ischium to adductor longus as the anterior-posterior reference. Record the goniometer measurement on the lateral aspect indicating iliofemoral angle. An ischial-ramus angle can be measured, or averages can be used as indicated. Measure a ischium to distal end length. Use 3 to 4 cm increments to define circumference measurement height and record all under slight tension. Record ischium and center knee to floor for prosthesis setup purposes. Doing a precast simulation of hand positioning will help the practitioner and patient's understanding of key landmarks and positions during the casting. One digit should capture the inferior part of the ischium and another the medial aspect, with the residuum in an adducted position with minimum flexion. When applying the plaster of Paris bandages, take caution not to create bridging over the key areas. Elastic bandages can be used where curvature of the POP is required. Taking an anterior approach, the practitioner places digits concurrent with the precast simulation, and the thumb is used to match the cast with the anatomy in the scarpus area, avoiding pressure on the adductor longus. Constantly revise the posture, such as hip position, adduction and flexion angles during the casting process. the transverse plane, a line is drawn inferior the cast to indicate a line of progression as reference. A single sagittal cut can be made on the sound side of the cast for easiest removal. Examine the finger positioning on the cast. The third digit is positioned inferior to the ischium and the second medial to the ischial ramus, with counter pressure on the lateral aspect using a flat hand on the femur shaft. Create a flat surface to close the cast parallel to the line of progression. Match flexion and adduction angles on the cast filling position with pipe as neutral reference. Transfer the line of progression to the positive cast and check with the medial proximal surface. Remove any excessive plaster parallel to the coronal and sagittal planes. On the ischial containment measurement form, calculate the reduction with proximal circumference minus 3 to 5% depending on the tissue consistency, and reduce the formula gradually to 3%, 2%, 1% and 0% distally. These are the goal measurements for the positive model rectification. During this demonstration, modification is done systematically. First, starting with plaster removal around the greater trochanter area. Mark the circumference heights and flatten the lateral shaft of the femur. These two modified planes should aim to reflect in the iliofemoral measurement. Check medial lateral measurements. The ramus angle can be checked with line of progression as reference. The sub-ischial plane should aim to compress the adductors. Check the mediolateral measurement 60 mm inferior to ischium. Define posterior trimline following the gluteal curvature. This plane should be modified as a convex shape. Be sure not to constrict the medial hamstring tendon. Modify the anterior wall, avoiding adductor longus. Using the anterior superior iliac spine as reference will help define the trimline. Avoid creating pressure on the distal cut end of the femur. Constantly check circumference and how they correspond with the goal circumferences. Summary of positive cast plaster removal. 1. The plane around the greater trochanter. 2. The gluteal pocket plane should form a concavity extending along the femur. 3. the sub-ischial area as triangular flat. Four, relieve adductor longus and distal cut end of femur with additional plaster. Finally, smooth the plaster model. In the sagittal plane, align the prosthesis using trochanter, knee and posterior third of the foot as reference points. Match the measured flexion angle in the socket with an added 5 degrees. In the coronal plane, bisect the socket at ischial level. This forms a reference point that should align with the center of the knee and the ankle. Apply clean and simple alcohol spray to the seal ring before donning. Check the sagittal static alignment. Mark the final trim line of the liner 1 cm above the socket trim line. After trimming of the liner, place the liner on a cling filmed cast to simulate upper thigh circumference and seal using adhesive silicone. Repeat the trimming process if need be. Examine the seal pressure against the socket wall, which should be consistent around the circumference. No excessive bulging should be noted at place of tissue exiting the socket. Examine any range of motion impairments caused by the socket.